Okay, so the idea is to start the new chapter for this random signals and process course, and this is the second chapter of probability and stochastic process of the Yates and Goodman book. Okay, so in this chapter, at first we'll start with what is a random variable. Okay, so what is a random variable? We want to start with this one. What is random variable? What do you mean by random? Do you have any idea about random?
It is like it
Random,
can be anything.
Unpredictable.
unpredictable. It can be anything. Yes, that is true. I mean, when something you want to guess, I mean, you cannot guess with 100% probability that this is that one. So actually, random things comes from the probability. Why we have learned the probability things in the first case? Because we want to work with the random variable. And what is the variable? Variable means whose value varies. Okay, so random variable is something, some variable whose value varies randomly. Okay, so a random variable consists of an experiment with a probability measure P of something defined on a sample space S and a function that assigns a real number to each outcome in the sample space of the experiment. What is that? The idea is, you know, the sample space is that is space where all the possible outcomes are there. Okay, so when you are making an experiment, definitely you are having some outcome, and if you take all the outcomes, that actually will make the sample space. Now the thing is, if you make a function that assigns a real number to each outcome, you know that in a sample space we have many outcomes, and every outcome will have a real number assigned to it in the sample space of the experiment. So if I'm talking about tossing a coin, then I can have the head or tail outcome, and for all these outcomes we will assign a value, we will assign a real number against it, and that is the probability of that particular outcome, and that actually will say it is a random variable. So a random variable consists, we have to do at first one experiment, and then we'll have some outcomes, and then there will be a sample space where all the outcomes are there, and then with all these outcomes we will assign a real number against all these outcomes, which will be the probability of that outcome. That will be the random variable. Okay, so uh, this range of random variable, we can understand that a random variable is something, say for example, I'm talking about x. X is a random variable, or capital X, and this X can have many random values, isn't it? Like say for example, the values can be say 1, 2, 3, 4, 5, and 6. Say for example, I'm just rolling a dice, and that dice is having many dots over there. Okay, and then I'm talking about that what are the outcomes can be 1, 2, 3, 4, 5, 6. These are the outcomes, and these are some random values. When you roll a die, which one is going to come, you don't know. So it is a random outcome. Okay, so this X is a random variable. Variable means the value of the variable changes. That one is called a variable, and these values are some random values. Okay, so this random variable will have some random values, and this every random value will have a probability of that one, or probability of two, or probability of three, like this. Now, this random variable can have many random values. These random values collectively are called the range of random variable. Range of random variable. Okay, and this range of random variable, look at this one. The set of possible values of a random variable x is the range of x. We often consider more than one random variable at a time. So there can be x random variable, there can be y random variable. So if x is a random variable, y is a random variable, then to specify the range of x, we'll consider it s of x, or range of y, s of y. So this s actually is the range, and in the subscript we are having the random variable. So sx or sy, these are called random variable of x, sorry, range of random variable x and range of random variable y. Can you understand?
Yes, sir.
Say it again.
Again, which part? I will again tell random variable or range of random variable.
Range of.
Range of random variable. Say for example, you are tossing a coin. Okay, and you are getting head or tail. Is there any other possibility there?
No.
No. So these are the range of this particular random variable. I am tossing a coin. If the random variable is x, and that x will contain head and tail, and there is no other outcome possible, so these are called the range of x. Range of x equal to head, tail. Do you agree? Do you understand?
Yes.
Okay. All right. So I hope you have understood what is random variable and what is the range of random variable. Now we'll go for the next slide. Now we have understood the random variable. Random variable is what? It's a variable. I mean, you in the computer programming, you have already seen how to take a variable. The variable is something whose value changes over time, isn't it? So random variable is something whose value generates randomly. What value it will come, we don't know. So these random variable things can be characterized, or can be categorized in different ways, like discrete random variable or continuous random variable. What is a discrete random variable? Say for example, the random variable x. Okay, and this random variable has some values like 1, 2, 3, 4, 5, 6. Okay, and when I'm putting the values like 1, its probability is 1 by 6, another 2, 1 by 6, 3, 1 by 6, 4, 1 by 6, and then 5, and then 6. So all these values are some discrete values. Look at that. In between 1 and 2, there is no probability. There is no value. Between 2 and 3, there is no value. Between 3 and 4, there is no value. 4 and 5, no value. 5 and 6, no value. Other more than 5, 6, no value. Less than 1, no value. So it is not actually continuous. If the things is like this one, they are continuous. There is no gap between them. Isn't it? This is a continuous random variable. This is called continuous random variable. And this is called discrete random variable. Discrete means not continuous. It means at a point, so you will have will find some value, and some other point you will not find some value. Okay, so discrete, it is not continuous. Say for example, if the sinusoidal wave is like this, the value is like this. This is what? Discrete values. But if the sinusoidal wave is something like this, it is continuous. There is no gap between one value and another value. But here, there is a gap between one value and another value. So, if the x is a discrete random variable, then the range of x is a countable set. Okay, so we can count them. In the discrete random variable, we can sometimes count them. I mean, we can count them actually. Okay, so this discrete random variable is, you can understand that there are discrete values, discrete numbers. Yes. Any question? No. All right. So the thing is, it can be either discrete or continuous random variable. Similarly, another category is finite and infinite random variable. If it is a finite random variable, then actually the number will be countable. We can count it. I mean, count it means we can see that they are not infinite, they are finite random variable. Say for example, like our grade in this triple E, I mean, in this math 4421. Okay, the grade can be A plus, A minus, A, B plus, B, B minus, C plus, C, D, F. There are 10 possible grades here. We can count it as the 10 possible grades. It is not infinite. So if we say that this random variable S is definitely a finite random variable, but say for example, a continuous random variable between 1 and 5, if you want to find out how many possible values are there, then these values must be infinite number of values. Okay, so if the number of values or the number of random values are infinite, then we will say that it is a infinite random variable. So there are two categories. One is discrete or continuous. Another one is finite or infinite random variable. Is there any question? Is there any question?
No, sir.
If not, then we can move on to the next slide.
So,
Yes.
the finite and the infinite is not.
You're not understanding?
No, I don't.
Tell me, what is infinite? My question is, what is infinite?
It cannot be counted.
It cannot,
Be counted.
it cannot be found.
Yeah.
It's not a good
Like
answer. What is infinite? Say for example, um, say for example, 1, 2, 3, 4, 5, 6, 7, 8. If I go like this, what is the end? What is the end? Where will it go?
go to him.
It will go to infinite.
Yes.
Do you understand that one?
Yes, sir.
So if it goes to infinite, it means actually we cannot actually end that one. It is infinite. So if one random variable has some values that is going to infinite, that is a infinite random variable. Say for example, this is y-axis and this one is x-axis. Now I am having one value, we are having some value. For 2, I am having another value. For 3, I am having another value. For 4, I am having another value. For 5, I am having another value. Like this, I am going and going, and the values are changing and changing, and there is no limit. that kind of random variable is called infinite random variable. And if I can end up to this, up to 6 or 7 or 10 or 100 or 1000, if there is a limit, then that is called finite random variable. Do you agree? Do you understand?
Yes, sir.
Okay, so finite and infinite random variable are depending on finite or infinite value of x. Whether this one is like this, or I am ending that one at some value xn. If I am ending that one, that is a finite random variable. If I cannot end like this, it is infinite random variable. Remember one thing, discrete random variable can also be an infinite random variable. Okay. Is there any other question? I am going to the next slide. Okay. All right. Example 2.5. Okay, let's discuss about this problem. Suppose we observe 3 calls at a telephone switch where voice calls and data calls are equally likely. Okay, let's do one thing. I want to stop the sharing and I want to do one thing. Okay, let's stop the sharing and I want to just a minute. I just want to make some change. Okay. Share. Where is the sound? Okay, can you see it? Can you see the slides?
Yes, sir.
Okay. Slide. Okay, that's what I was talking about. So it is example 2.5. All right. So the thing is, what I want to do is something like this one. Suppose we observe 3 calls at a telephone switch where voice calls and data calls are equally likely. So there are three call. There are 3 call. Okay, and every call can be either a voice call or a data call. Either a voice call, data call. Either a voice call or data call. Okay. All right. So what are the combination possible? What are the possible combinations? How many combinations will be there?
8.
8. Very good. What are the combinations? D, 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 V, D, V, D, D, V, V. Then V, D, D, V, D, V, 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 D, V, V, V. Do you agree?
Yes, sir.
Okay. So these are the combinations. 8 combinations. Okay. Okay. Now tell me, what is the probability of a DDD?
8 by
Probability
1.
of this, say for example, Y. Okay. Anyway, probability of this one. 1 by 8. Do you agree?
Yes,
Yes,
sir.
sir.
What is the probability of DDV?
Same.
1 by 8.
Same. So all these are with the same probability. Okay, number one. Number two is, let X denote the number of voice call. Okay, what is X? The number of voice call is X. So if I say that what is the random variable X, then what is this one?
0.
Right, very good, 0. This is
1.
1,
One.
this is
1.
1, this one
2.
2, this one
1.
1,
2.
2,
2. 3.
3. Okay, very good. So this X has 0, 1, 1, 2, 1, 2, 2, 3. Now, if I want to say that what is the range of X? Sx. Sx equal to what?
0 to
3.
1,
0.
2, 3. All the possible combinations, isn't it?
Yes, sir.
This is the range of X. Now tell me, what is the probability of 0?
1 by 8.
1 by 8. What is the probability of 1?
3 by 8.
3 by 8, because there are 3 ones, isn't it? What about the probability of 2?
3 by 8.
3
3
by
by
8 again. And what is the probability of 3?
1 by 8. 1 by 8.
8. So we are having the range of X and then the probabilities of X as well. Okay, so we can do that. Now, what is Y?
3.
3. Then 2,
2. 2.
1, 2, 1, 1, 0. Do you agree?
Yes, sir.
Because this Y is the number of data calls, isn't it? Okay. So can you say again what is the range of Y?
0, 1, 2,
0, 1, 2, 3.
0, 1, 2, 3. Isn't it? This is the range of Y. What is the probability of 0?
1 by 8.
1 by 8. What is the probability of 1?
3 by 8.
3 by 8. What is the probability of 2?
3 by 8.
Again 3 by 8. What is the probability of 3?
1 by 8.
Again 1 by 8. So the same thing actually happening again. So we can know the range of Y. We can know the probabilities of different values of Y as well. Now, the third thing has told that R equal to X and Y, X into Y. Remember one thing, if you multiply two random variable, a third random variable generates. So this is the third random variable. So R is also a random variable. Random variable. Okay. So this R is also a random variable. Now the thing is, if you want to find out the value of R, what is the value of R?
0.
0.
0.
0,
2, 2, 2.
2, 2, 2,
2,
2,
2,
2,
0.
2, 0. So if I want to find out what is the range of R,
0, 2.
0, 2. What is the probability of 0?
2 by 8.
2 by
1 by
8.
4.
What about probability of 2?
6 by 8.
6 by 8. That is 1 by 4. And that will be 3 by 4. Okay. So for this particular example, we have found out all these results. Is there any question regarding anything about this topic? Nothing.
No, sir.
Nothing. Now actually what I have done, that now if I do it, I mean this is all clear, and then if I take the find, then it actually is coming. This is the thing that we we have already drawn here. And then now we'll go for the probability mass function. What is the probability mass function? Probability mass function um, um, is the list of probability for all the random values. Okay, so here actually it is not written like this. I will say that PMF is the list of all probabilities for all the random values. Okay, so PMF is the list of all probabilities for all the random values, and we will call it probability of x, small x will be equal to probability of x equal to x. What is that? That is actually, I'm making a list. Say for example, in the previous example that we have seen, what was the different values of x? 0, 1, 2, 3. Then we have seen that the probability of 0 was 1 by 8 for x equal to 0, and then 3 by 8 for x equal to 1, 5 by 8, 3 by 8 for x equal to 2, and then again 1 by 8 for x equal to 3. Can you remember? If I make that in a table, that will be called the PMF. Okay, and remember a very important thing that I haven't mentioned, which one is the thing is that I haven't mentioned is zero otherwise. This is very important term in the PMF. Why zero otherwise? Because you are actually fulfilling all the points. As I told you that for all the random variables, any random variable can have, and that it is telling these are the random variables for which there are values, and this one is zero otherwise means for other random variable, I mean for other random values, if it is possible, then for that there is no probability. There is zero probability for other random variables or not other random values. Okay, so that actually is giving a list of probabilities for all the random values, and that will be called probability mass function or PMF. Is it clear? Actually, it will be again shown by using this example 2.6. We have given by using x. We can also give it by using the r. PRR, that will be equal to, for r equal to 0 there was a probability, for r equal to 2 there was a probability. If you can remember, for r equal to 0 the probability was what? 1 by 4. For r equal to 2 the probability was 3 by 4. So if we write like this and then again 0 otherwise. Okay, so if you write it like this one in this format, that will be called as a probability mass function. And also you can draw the figure like this as well for making understand what is the probability mass function. Okay, look at this. For r equal to 0, this is the r axis, this is the probability axis. For r equal to 0, probability is 1 by 4 or 0.25, and then for r equal to 2, the probability is 0.75 or 3 by 4. All right, so I think it is clear now. If you have any question, you can ask. No question. So I'm going to the next slide. Okay, now consider these following experiments. In these experiments, look at this. The first one that we are talking about, flip a coin and let it land on a table. Observe whether the side facing up is heads or tails. Let X be the number of head observed. So you are doing a single test. So how many maximum head can you can observe?
1,
One. So and what are the other values?
0.
0. So either you can see the head or you cannot see the head. If you can see the head, the number of head will be 1. If you are seeing the tail, it means the number of head will be equal to 0. So in this particular example, if I say the number of heads is the random variable, then the random variable X will be either equal to 0 or equal to 1. Do you agree?
Yes, sir.
All right. Go for the experiment, example or experiment number 2. Select a student at random and find out her telephone number. Let X equal to 0 if the last digit is even. Otherwise, X equal to 1. So what is the X? X is the last, X is something which is coming from the last digit of the telephone number. And if it is odd, it is 1. If it is even, it is 0. So can you tell me what is the random variable values here in this experiment?
0 to 9,
9. Why the 9 will come?
because it's a random variable as in the number, last digits of the phone number.
I'm not talking about the last digit of the phone number is the random variable. The random variable is something which is equal to 0 if the last digit is even. Otherwise, it is equal to 1.
So, sir, range
In that
will be
will
X,
be
0 and 1.
0 and 1. So actually, the possible values of X will be equal to 0 or 1. Like the previous example, isn't it? In the previous example also, the value of X was equal to 1 or 0. In this example also, the value of X equal to 1 or 0. Okay. Now tell me, what is the value of, what is the case of this example or experiment number 3? Observe one bit transmitted by a modem that is downloading a file from the internet. Let X be the value of the bit. Okay. So can you tell me what the value of X can be?
0 or 1.
0 or 1, right? Like the similar case in the previous 2 examples. The thing is, all those 3 examples, we are having so in all these 3 examples, we are having the similar kind of probability mass function. Do you agree or not?
Yes, sir.
The mass function we are having for all these cases, the same mass probability mass function, PMF. If X equal to 0 or X equal to 1. And if they are equally likely, they will be equal, they will be half and half and 0 otherwise. So remember one thing, this PMF actually deals with the characteristics of the experiment. From the PMF, we can find out the mean, the standard deviation, the variance, the other values as well. So when these 3 experiment has the same PMF, that means by a single PMF, I can explain all these experiments. That's why a group of experiment can be explained by a single PMF. Like this, there are other PMFs as well, which are able to explain many groups. So in this way, actually, if we can group different experiment, then actually it is easy to explain different phenomena. And these groups are called families of random variable. For the discrete random variable, we call it families of okay, the families of discrete random variables. And these are what? These are Bernoulli random variable, geometric random variable, binomial random variable, Pascal random variable, discrete uniform random variable, and then the Poisson random variable. All these random variables are discrete in nature. And today we'll see the first three random variables. Okay, let's start with this first one. Bernoulli random variable. Before going to the explanation, we will start with an example. Okay, what is the example? Look at this one. Suppose you test one circuit with probability P, the circuit is rejected. Let X be the number of rejected circuits in one test. What is P of X? Again, I'm telling. Suppose you test one circuit. Very important thing is one circuit. With probability P, the circuit is rejected. Okay. Let X be the number of rejected circuit in one test. So X is what? Number of rejected circuit in one test. So you're talking about one single test, and we can have either accept or reject. Then if I'm talking about number of rejected tests, what is the value of X? What is the value of X?
0 or 1.
Right, 1 or 0. So this is the same family that the previous three examples for. And this kind of random variable is called Bernoulli random variable. There will be only two options, x equal to 0 or x equal to 1. And look at this one. 1 means what? Number of rejection equal to 1. So the rejection probability is P. So when x equal to 1, then the probability will be P. Then the acceptance probability will be 1 minus P. You can understand this one. And we know that for PMF, we have to add this 0 otherwise. Okay, so this is the PMF of a Bernoulli random variable. And this random variable actually explained with a single circuit or single test. Okay, so if the P equal to half, then that will be half and half for x equal to 1 and x equal to 0. For a normal toss of a coin, that is also a Bernoulli random variable. Okay, so this category of cases will be called Bernoulli random variable. If there is any question, you can ask.
So, sir, any situation where there's only one trial and only rejecting or accepting, that is a Bernoulli
Right,
random variable.
right. Single test, and there are only two options. Then actually it is going for Bernoulli random variable.
So, sir, in the last sentence, there's written the number of circuits rejected in one test.
Right,
So the number of circuits rejected, meaning the one circuit being tested, and that one circuit will be either rejected or accepted.
right, right.
Okay, sir.
Okay, so as there is a number of circuits in one test, so it can be either 1 or 0. And this kind of problem will be Bernoulli random variable. Is there any other questions? If not, I can go to the next slide. Okay, Now we are going for a different kind of random variable. It is called the geometric random variable. We again start with this example 2.11. Okay. In a test of integrated circuits, there is a probability P that each circuit is rejected. Let Y equal the number of tests up to and including the first test that discovers a reject. Very important and very critical kind of language this is. Y is the random variable and this Y equals the number of tests. Number of tests. Okay. Y equal the number of tests up to and including the first test. So Y is the number of tests. Y is equal to the number of tests. Okay. Y is the number of tests. Remember one thing, up to and including the first test that discovers a reject. Discovers a reject means what?
The first test is already rejected. I mean, the outcome was rejected.
Not already, when the first test will be rejected. Say for example, I'm talking about first test and it is accepted. What is the value of Y?
0.
How can you say that?
Sir,
It's
because
one.
the event Y is including the first test rejected.
So Y is equal to the number of tests.
So sir, why should be 1? Because the first circuit has been tested.
Y is not the number of tested circuit. Y is the number of tested circuit when you will discover a reject.
Oh.
Have you discovered a reject yet?
No,
No
sir.
sir, so why should
Why will Y be equal to 0? Because there are options. You can go for test again. Isn't it? So if A is a reject, I mean, in the first test is a reject, what is the value of Y?
1.
So case 1, I will say first test reject. Y equals to what?
1.
Y equals to 1. Because your job is to get a reject. Your job is to discover a reject. And you have already discovered. So you will stop. Y equals to 1. Khalas. But the problem is, if you get an accept, you cannot stop. You have to go for the second test. So you're testing. If the second test is a reject, case 2, second, what is that? First test reject, no, first test accept, and second test reject. What is Y?
1.
Why 1?
2?
You have already tested two tests because second test is a reject. So what is Y?
2.
Y is 2 because you have already tested the second one and you have got the reject. That's why you are stopping. You are able to calculate Y because you have got the reject. But if the second test is not a reject, if it is an accepted one, what is Y? Case 3. What is that? First test accept, second test also accept. What is Y?
We cannot tell, so we have to
We
keep
cannot
going.
tell. We have to keep going. We have to go for third test. That means if it is reject, say third one is reject. What is Y?
3.
3.
Y is 3 now. So if third test is an accept, we have to go again for the next case. So number of y actually is a variable. Y depends on what is the outcome, isn't it? Now the thing is, when y equals to 1, what is the probability of y?
So
Tell me.
that upper equation.
No, not upper equation.
So
When y equals to 1, when y equals to 1 means what? The first one is a
reject.
reject. This is the case 1.
Yes.
When y equals to 1 means first one is a reject.
So it should be half.
What is the probability? It
So
actually may not be
we
half.
haven't given the probability.
The probability is given. Look at that. There is a probability P that each circuit is rejected.
Oh, right. So P, it will be P.
It will be P. When y equals to 2, what is the probability?
P into 1 minus P.
Because this is the line, then it will follow. This is the line. If the y equals to 1, this is the line. If y equals to 2, this is the line. And there are two branches. One is accepted, one is rejected. What is the accepted probability? 1 minus
1
P.
minus P.
What is the rejected probability?
P.
P. So it will be P into 1 minus P.
So sir,
Do you
it comes
agree?
from the conditional probability.
Actually, not conditional probability. It is coming from, you can say, branch probability. You can say conditional probability, no problem.
So sequential probability.
Sequential probability, you can say. It's actually sequential probability. You can say that this rejection is a condition that the first one is accepted. You can write that in that way also. You can say it as a conditional probability as well, but they're independent. Okay. Now tell me, when y equal to 3, then what is Py?
P into 1 minus P whole square.
That means first one accept, 1 minus P, second one accept, 1 minus P, third one reject. This is P. Therefore, 1P and 1 minus P. Isn't it? Similarly, can I say that y equal to 4 if it is like that? Then of course Py will be equal to what? P into 1 minus P
whole
to the
cube.
power 3. If I say y equals to y, then Py will be equal to what?
P to the power 1 minus P into y
P
minus
into
1.
1 minus P to the power
Y
y
minus 1.
minus 1. Look at that. This 3 is always a 1 short of this y value. Isn't it? That's why we can say, if it is a y, general case, I can say it like this. Okay. So this is for the example, and the variable y. If I say the variable is x, then it should be like this. And remember one thing, this is the probability. When I will write the PMF, then 0 otherwise will come. You understand it? Do you agree with me?
Yes, sir.
So this kind of random variable is called geometric random variable, because it is geometrically increasing, multiplying and multiplying and multiplying. Okay, so this geometric random variable is something like this. Is it clear?
Yes, sir.
Is there any question? Hopefully no question is there. So we can say that the result is something like this one. You can understand if you go through. The third random variable is the binomial random variable. In this case also, we read the example first. Suppose we test n circuits. Okay, we test n circuits, and each circuit is rejected with probability P, independent of the results of the other test. We know this one. Then let So we are testing n circuits. Let k equal the number of rejects. So out of n tests, k is rejected in the n tests. Find the PMF of k. Okay. So in this understanding, we will write it like this one. We're talking about n number of tests. Let's start with n equals to 7, k equals to, let's say, 3. So n number of tests I'm talking about 3, 4, 5, 6, 7. Okay. Now I'm testing 7 circuits, and out of 7 circuits, I'm finding 3 circuit as reject. This 3 circuit can be anywhere, here, or here, or anywhere. So at first I want to find out these 3 circuit. How do we know how many combinations will be there of n
7C3.
of three reject out of 7 test?
7C3.
Isn't it 7C3? Do you agree?
Yes, sir.
Out of 7 tests, 3 circuit will be rejected. They will definitely be 7C3. Remember one thing: if this is rejected and this is rejected, actually, if we just change the place, that will not change anything. That's why it is 7C3, not 7P3. Okay. So 7C3 different kinds of combination. Let us think about one single combination is something like this one. Say this is uh, rejection means what? Individual probability is P.
P.
So this is rejected, and also say this is rejected. Okay. Say these 3 circuits are rejected. Definitely the others are accepted. So I can say these are with probability 1 minus P. Can we say that?
Yes, sir.
So these are with accepted, and accepted, and these are rejected. So, and this is a single combination. You know, whatever the probability will be there, that has to be multiplied by this one. So now tell me, what is the probability of this particular combination? First one,
P to the
reject.
power 3 into
Definitely 1 minus P into 1 minus P into P into 1 minus P into P into 1 minus P. Do you agree?
yes, sir.
That is what? P to the power 3,
3,
1 minus P to the power
4
4
into 7C3.
into, so total number of probability, or total probability will be what? 7C3 multiplied by P3 1 minus P to the power 4. Now, at first we talked about n equal to 7 and k equal to 3. Now, if I want to generalize, isn't it something like this one? NC3, NCK, 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 then P to the power K, 1 minus P to the power N minus K. Can I say it like that?
Yes, sir.
The same thing actually. So this is the probability of K for this particular kind of distribution. And this kind of distribution is called binomial distribution, because we are taking something from something. There is n, there is k. So if the uh, 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 situation is something like I am taking some from many, then it's a kind of NCK. Then we will call it binomial kind of distribution, binomial random variable, and the probability will be this one. And you can see that if the k is replaced by x, then actually you will see this one. And remember, nx, this is the same as ncx. Okay. So is there any question regarding binomial random variable?
Sir, does the naming also come from the expression looks like a binomial
Yes,
expansion?
actually. The name also came from the binomial looking. Is there any other question? If no question is there, I'm stopping here. You can actually see the result of this one. Actually, it is the same thing as this one. So in the next class, we'll start with the fourth kind of random variable kind of thing. Okay, and remember one thing. So I'm going back to the thing. Here they are talking about the probability, but PMF, as they are talking about PMF, what they have missed, it should be something like zero otherwise. That is for x equal to um, um, I mean 1, 2, 3, something like that, and then zero otherwise. This should be there. So there is a mistake in the book. All right. So this is a PMF we are expressing. So they are talking about it's a PMF of x. So it should be some zero otherwise should be included here. Otherwise, it is only a probability. Is there any question? So if there is no question, then we can stop the class today. And I'm going to give you the attendance for today. So your section B.